Assalamualaikum. My name is Imran Husaini. So I will explain about the introduction. The introduction is this project is focused on recognizing human emotion from facial images. So emotion detection is useful in real world applications like mental health monitoring, smart classroom, and interactive devices like virtual assistants. For project objectives, we have three objectives. First is to build a deep learning model that can recognize emotions from facial expressions only. Then the second one is to train the model using a CNN, which is a convolutional neural network. And the last one is our objective is to test the model on new images and measures how well it works.
Assalamualaikum, my name is Al Hakim. Now I'll continue on the code explanation. On the left side, this code will set up an image recognition environment using Python. We also install the image AI library and the necessary TensorFlow tools, which will import various modules for image processing and also help us on the building deep learning models. After that, it also will set to working the directory and using Google Colabs to upload the function, and also will let us to upload a zip file specifically using the FAIR 2013 dataset. After that, on the right side of the code, this code set up the current working directory, which define path for the training and testing dataset folders, and it will print the names of the emotion categories in each. So for the next part, we're still using the ResNet 50 model for the facial emotion classification, and we start by defining an input layer on the 48x48 grayscale images, and also we apply the convert 2D layers using the ReLU, which is rectified linear unit, to extract the features. We're also using the max pooling layer to reduce the image size while keeping the key details. And then we are using residual blocks to help function like ResNet block to mimic the ResNet 50 architecture. And finally, we are using three functions such like global average pooling, dense layer, and softmax to output the class probabilities. Moving on to the next part, as you can see here, this code will be prepared for the training and testing data for the model using the image data generator. It will resize the image following to the 48x48 that will convert them to grayscale and normalize into the pixel values. We're also using several functions such as an horizontal flip equal to true, which augments training data by flipping the images, and also like color model grayscale, which will convert the image to grayscale. And we're also using the class mode like categorical, which will label the hot one encoded for the classification. This setup will help the model to learn better and generalize well. So for this next part, this code will build and compile a custom ResNet 50 deep learning model, which will design to classify facial expression into 7 emotion. And we are using the key building blocks, which are ResNet module, ResNet first block first module, and also ResNet block functions. This will create a residual connection, which are a core idea in the ResNet, and it also will help the model to learn deeper patterns without performance issues. And the ResNet 50 functions will structure the full model, which it start with the convert the 2D layer and the max pooling, and it will end with a global average pooling layer and a dense softmax layer to predict the 7 emotion classes. And finally, model summary function will show the architecture, which help us to verify the model's layer pattern and the parameter. This setup also will allow the model to learn complex features in facial images effectively and make accurate emotion prediction. On the left side, this code will define the dictionary that map each emotion, labeling from 0 to 6, and it will correspond to emotion name like happy, sad, or neutral. And we're also using JSON-DUMP to save this mapping to a JSON file called FAIR 2013 class index, and this file can be used for the used later to interpret model prediction by converting numeric outputs back to readable emotion labels. And on the right side, as we can see, this code will compile and train the ResNet 50 model for facial emotion recognition using the FER 2013 dataset. And it also will set the input shape and number of emotion classes. We also using model fit to train the model for one epoch, and using model save weight that save the learn weight to a file for future use. This complete the training phase and of the facial emotion detection model. So for these two code above, this code perform inference on a single image using train ResNet 50 emotion model. On the code run inference for image path, it loads the safe model weight and then read the pre-processed grayscale image. It also will display image using matplotlib and then predict the motion using model predict. And it also will decode prediction for which the convert numeric prediction into readable labels using the safe JSON mapping. And it finally will print out the probability of each motion, showing how confident the model for each class. And the code below, it's on this code, it will let us to upload an image and then run the train model to predict the emotion that can be shown in that image using run inference for.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Fatih Irfan bin Norman. So I will do the demonstration for this assignment 3. So for the first one right here, we can see that I install the image AI and then we import everything that we need. So for this assignment, we use object deductions and then we also import the Keras models right here. And then after finish import everything that we need, I try to import the zip file that I already uploaded in my folder. Then we use FER 2013 dataset to implement these face recognitions. And then after finish upload the zip files, we start to unzip all the file. Actually following the week 12 activity 2 examples for running these things. And then we start to check the structure folder inside the FER 2013. There is test and trend folder, and then inside the test and trend folder right here, we can see there is a lot more files or image inside it. And then we start to set the dataset path right here, which is for trend and test. And then we verify whether the datasets actually exist in this tutorial collab. So we can see there is a 7 emotion right here, which is sad, neutral, happy, surprised, disgust, angry, and fear. So it shows that there is successfully upload all the files. To finish that, we start for the execution parts. And then for this code, we try to convert the grayscale image to 48 times 48. Then after finish converting it, we use the image data generator for the grayscale image. And then we found there is 28,000 belong to 7 plus and then 7,000 belong to 7 plus for test. This is for trend and test actually. Then after finish it, we start to train the model. Here we can see the output right here. There is total of 23,000 and then the trainable is just 23,500 and then the missing item there is a count like 53,000. And then we start to save the class index in a JSON right here. There is 7 emotion. And then we start to train again the models, but this time with the current input and class count, which is 7 class. And then I just run one epoch because there is take a lot of time to just run one epoch. So it's not really that accurate, but it's okay to run these assignments. So after finish to train these models, I can start to run the infer to predict the model, which is using this code. And then we start uploading the listed image, which is I upload public as image, which is you can see right here. So the final output, we can see it can predict this image to have 75% sphere. So in the conclusion, it's not really accurate because maybe I just run one epoch, but it still can see it can predict the image right here. Okay, so I think that's all. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Adli. So in this project, we can conclude that we successfully implement a CNN model for facial emotion recognition by using ResNet 50 architecture to improve model training and performance. So our output, we get a
7 prediction emotion and confidence from the image, which is the first one is fear, angry, natural, surprise, sad, happy, and lastly is disgust. And second one is we achieve meaningful prediction on unseen test image. Even though we train the model for what a push due to resource constraint, the model will still able to make meaningful prediction on new image. And we encounter challenge such as limited GPU time and low resolution dataset image. Okay, last but not least, future work includes training with more a push and applying data augmentation to improve performance in the future. We can involve training model for more approach and applying data augmentation techniques to increase the dataset diversity. I think that's all from our group. Thank you.